Hey, so today we start our unit on inequalities. And first thing we're going to do is just review the 4 different types of inequality symbols you see on your screen. We are going to take a look at how to graph an actual inequality, where we have a variable compared to a number. And then we're also going to take a look at how to solve inequalities and graph their solutions. All right, so first up, I want to just review the inequality symbols that you see here. We have the less than symbol, which is the one that is angled pointing to the left side. I know a lot of times you're kind of trained to think about whether it's the Pac-Man trying to eat the bigger number or the alligator trying to eat the larger number. We want to think of this as the pointy side is on the left-hand side. It's like the end of an arrow. Like if I were to draw an arrow, I would put a less than symbol if it's pointing to the left. Or if I draw an arrow pointing to the right, that would be a greater than symbol. Okay, so think about the end of an arrow and helping us decide what's less than, what's greater than. Now, anytime you have that same symbol, but you put the little line underneath it, that's like combining a less than symbol and an equal sign together to become what we call less than or equal to. Or perhaps the greater than symbol combined with part of an equal sign to become greater than or equal to. So the ways that I remember what's less than, what's greater than, is I think about the less than symbol points to the left, like the end of an arrow. The greater than symbol points to the right, again, like the end of an arrow pointing to the right. And if it has the little line or bar underneath it, we know that that means that equality is possible as well. So when we're graphing an inequality, not just an inequality symbol, but an actual statement like x is less than 4, for example, we want to identify the boundary number. And that boundary number is whatever value we're comparing to the variable. We're saying that x, or our solutions, are less than that number. Okay, so anything that's less than 4 would happen to be a solution to this. So 4 represents a boundary. So what we do is we place a circle on the number line at that boundary number. So right on the number 4, for example. However, there's 2 different types of circles we might draw. We might draw what's called an open circle, or we might draw what's called a closed circle. In other words, it's filled in. So it's an open circle if 4 is a boundary but not a solution. So we use that if it's what we call a strict inequality. So if it's a less than or a greater than, we use an open circle to show that 4 is the boundary, but 4 is not actually a solution. Now, if we change this to say x is less than or equal to 4, now we're saying that the boundary number of 4 could also be a solution. Because think about, what would you get if you put a 4 in the place of x here? Would you get a true statement? Is 4 less than or equal to 4? And yes, of course it is. So that boundary becomes a solution also, and we want to indicate that on the number line by drawing a closed circle anytime we have that equality that's possible as well. All right, so open circles for strict inequalities when it's not equal. Closed circles are filled in when the equality is there because we have the little line underneath the symbol. All right, and then the third step is after you identify the boundary and you place the correct type of circle, we have to draw a ray to represent where are all of these solutions. Now, we draw a ray to the left if you have either one of the less than symbols. Okay, so our less than symbols point to the left, and on the number line, that's where our smaller numbers are. Then we want to draw a ray to the right if we have one of our greater than symbols, because numbers that are greater than our boundary value are going to be to the right of it on a number line. Okay, so we have to decide 2 things based on our symbol, open or closed, and if we draw our ray or our arrow to the left or to the right. So let's practice. In this example, it says x is greater than 8. Notice it's pointing to the right, and to the right on the number line are your larger numbers. So the first thing we do is we notice 8 is the boundary. So I'm going to go ahead and put a circle on the 8, but I have to decide if it's supposed to be an open circle like I have it now, or if I have to fill it in. And for that, I look at the inequality symbol. The inequality symbol is a strict inequality. It says that the values of x have to be greater than 8. They can't equal 8. So that means my boundary of 8 is not actually a solution. So I want to leave it as an open circle to represent that 8 is not a solution, but everything that's greater than that is. So everything that's bigger than 8 will be to the right on the number line, like 9, 10, 11, 12, and so on. So I've graphed my inequality by showing the solutions are to the right of 8 on a number line. In my second example, my boundary number is 3. So I'm going to find 3 on my number line. Start by drawing a circle. You can put it right on the number line if you want. I just choose to put it above the number line so it's a little easier to see what I'm doing. Then I look at my inequality symbol. My inequality symbol tells me that 3, or my boundary, is actually a solution because of the equals bar on my inequality symbol. It's not just less than 3, it's x is less than or equal to 3. So I want to show that 3 is a possible solution by filling in the circle. And then I want to show that all of the other solutions are to the left of 3 because that's where everything is less than 3. So all the x values that are less than or equal to 3 will be to the left of 3 and including 3 on the number line. So I've shown what those solutions look like by shading or drawing an arrow in that direction. Here's just a few more. C is less than -6. -6 is my target value. Then I have to decide, is it an open or a closed circle? And because I have a strict inequality, in other words, it's not equal to -6. Remember, if it was equal, you'd have that little bar underneath. But that's not there. So we leave it as an open circle to show that -6 is a boundary, but it's not actually a solution too. And then we want to show where are all of the values for C? Where are all of the numbers that are less than -6? And that's going to be to the left. All right, last one's a little bit tricky because it says -2 is greater than or equal to m. When we graph inequalities, it's a lot easier to graph if we write the inequality first. So we are going to rewrite this inequality with the variable first. So m goes on the left. And if I look at my inequality symbol, it is the pointy side towards the m. So I have to reverse the inequality symbol so the pointy side is still pointing at the m, and it still has the bar underneath it for the equality piece. And then my target, my boundary, is still -2. So I'm going to start by drawing my circle at -2. And I realize that -2 is a solution because of the equals bar underneath it. So that means I need to fill in my circle, my boundary circle. And then I want to show which side of that boundary has all of my solutions. So if m is less than or equal to -2, the numbers that are less than -2 are to the left. And then the equals part just told me to fill in the circle. The last piece is taking what we just did and kind of working backwards. If you start with the graph of the inequality and we want to write the actual inequality sentence, here's what you do. Look at our hint down below. We have a variable first. We always want to write our variable on the left-hand side. Then we have the inequality symbol in the middle, whether that's less than, greater than, less than or equal to, greater than or equal to. And then we have our boundary number or value at the end on the right. So looking at our inequality graph on the top, the first one, I see my boundary circle is right at -2. So I'm going to pick a variable. I'm just going to use x, and I'm going to put -2 on the right. And now I have to decide what goes in the middle, what inequality symbol. Sorry, that's supposed to be a question mark. So I look at my graph and I notice that it is shaded to the right side of -2. So I want to draw my inequality that points to the right. That's my greater than symbol. Then I notice that my boundary is not actually a solution. It doesn't equal -2 because it's not filled in. So I do not use the equals bar on my inequality. It's just x is greater than -2. For the example down below, I see my target value is at -5. So I want to start by picking a variable. I'll use y this time. My boundary number on the right is -5. And now I have to decide what inequality symbol do I use. Well, I see that my arrow is drawn to the left of -5. So I'm going to draw my inequality symbol that points to the left. So that's my less than symbol. So y is less than -5 covers all of these solutions. But we have to keep in mind that we have that solution right at -5 because the -5 boundary is filled in, it's circled. So I just show that -5 can also be a solution by putting the equals bar underneath my inequality symbol. Y is less than or equal to -5. That's how we write inequalities from a graph.